Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 2 to infinity, e to the negative 5p dp. This is an improper integral, which we can quickly see by noticing there is an infinite limit of integration there. So we have to use the definition. So the integral is equal to the limit as b goes to infinity. The integral from 2 to b, e to the negative 5p dp. Now we can take some time to use the fundamental theorem of calculus to evaluate this integral. And we can do that over here. So we have the integral from 2 to b, e to the negative 5p dp. Doing a quick substitution by letting u equal negative 5p, du would then be negative 5 dp. And you take the derivative of negative 5p and get negative 5, slap a dp on at the end. So then we need to multiply on the inside by negative 5. That way we get negative 5 dp, that's our du. But to do that, we have to also divide by negative 5 on the outside, or multiply by negative 1/5. So our integral turns into negative 1/5. The integral on the new limits of integration, whatever they may be, e to the u du. Negative 1/5. The integral of e to the u is simply e to the u. Limits of integration. But now we have to get back to x's. Sorry, not x's, in this case p's. So e to the u is equal to negative 5p. And the limits of integration are from 2 to b. Okay, so that can go back over here into our improper integral expression. So the limit as b goes to infinity, negative 1/5 e to the negative 5p, evaluated from 2 to b. Remember that this notation means that you're going to substitute in the b first. That's the upper limit of integration. So e to the negative 5b minus, then you're going to substitute in the 2, the lower limit of integration, e to the negative 5 times 2. The negative exponent will actually drop the e to the 5b into the denominator. So 1 over e to the 5b. Minus the same thing happens on the term to the right. This is 1 over e to the 5 times 2, which is e to the 10. Here we know that b is going to infinity, so it's getting larger and larger. So as b goes to infinity, 5b is going to go to infinity. And e to the 5b will also go to infinity. So 1 over that will actually go to 0. 1 over something that's very large is actually very small. So 1 over something getting larger goes to 0. 1 over e to the 10 is a constant. And so when you take the limit of that, you remain constant. So negative 1/5 times negative 1 over e to the 10 is 1 over 5 e to the 10. So this tells us that the limit, and hence the improper integral that we started with, converges, and furthermore it's equal to 1 over 5 e to the 10. So our original integral was the integral from 2 to infinity, e to the negative 5p dp. So we can conclude the integral from 2 to infinity, e to the negative 5p dp converges because that limit converged, and the integral is equal to 1 over 5e to the 10th.